Alright, my name is Stevie Adam Samuel. You are once again welcome to my channel. If this is the first time you're watching my video, don't forget to subscribe. And also, don't forget to hit on the notification bell for updates. Alright, so consider this example in case you're given this one, A times A times A times A. So we have 1, 2, 3, 4. So this one, it means A to the power 4. Now what this one means is that the number of times this number or this variable is multiplying itself. So it means the number of times A is multiplying itself. So the 4 here means that A is multiplying itself 4 times. Alright, so in case we're given, let's say, t to the power 5. Now this one is telling us that this t is multiplying itself the number of times, that is 5. Alright, so this one is the same as t times t times t times t. Alright, so 1, 2, 3, 4, 5, so 5. Alright. So we call the down one base and this one index. Alright, or power. Alright. So this one means that A is multiplying itself 4 times. Alright, so this one is power or index and this one is base. So this one will send us a topic called indices. So today we are going to look at a topic called indices. So this one is the base and this one is the power. Alright. So let's quickly look at the laws of indices. Now the first law I will talk about is A to the power C times A to the power N. Now let's work something here. Now this one is base, this one is base. So what can you say about the base? The bases are the same. And the law says that if the bases are the same and they are multiplying, you only pick one of the bases. So I'll pick one. Then I'll add the exponents. So C plus N. Alright, so in case we're given, let's see, 5 to the power 7 times 5 to the power 2. This one, since I have 5 here, 5 there, I'll just pick one, then add the base, which is 7 plus 2, which is 9. Alright, so this one means that 5 will multiply itself 9 times. Alright, so this one is also the same as 5 multiplying itself 7 times. Then this one, 5 multiplying itself 2 times. If you combine, you get this one. Alright, so that's the first law. Now the second law is division. In case we are given A to the power C divided by A to the power N. Alright. So this one, we have the same basis, so I'll pick one. Now let's check something here. This one is multiplication and this one is division. And the law says that if it is division, you just subtract the exponent. So C minus N. Alright. So let me summarize this one. In case we are given division, will tend to subtraction, and multiplication also tend to addition. Alright. That is summary of this one. So this one, in case we are given, let's say 2 to the power 2 divided by 2 to the power 5. So this one is straight away 2 to the power 2 minus 5 because I have equal bases, so I'll pick only one. So I will subtract the exponent. So 2 minus 5 is minus 3. So 2 to the power minus 3. Alright. Now let's move on. Now before we move on, this one is division. This one is the same as or A to the power C over A to the power N. And the same as This one is division and division, they are the same. I'll just pick one and subtract the exponents. So this one is the same as this one. Alright. So the third law. So in case we are given, let's say, a to the power x times t. Alright. Now, this one is a power, this one is a power. So the law says that this one can multiply this. So this one is s times t. So this one is same as a s. Alright, a s. So in case of using 6 to the power 4, then I have the all to the power 2. This one is the same as 6, then multiply 4 times 2, which is 8. Alright, so that is that. Now let's consider this example. Now, we have this one. So this one is the third law. So this one is to the power 2 all times the power 4 divided by this one. So this one is the same as 2 to the power. So 3 times 4 is 8. So this one we multiply this that. So division sign will come. And this one we have this 2 to the power 5. So this one is division, and we know division is subtraction. We are going to subtract the exponents. So this one is straight away 2 to the power 8 minus 5. So 8 minus 5 is 3. Alright. So this one, alright. So we have 5 to the power 4 divided by 5 to the power 3. Alright. So this one will cancel this. So we are left with 8 to the power 4 divided by 8 to the power 3. So this one, I have 4 here, I have 3 here. So I have 8 to the power 4 minus 3. So which is 8 to the power 1. Alright. So 8 to the power 1. Yes. Alright. Now let's move on. So I have 6 to the power 4 times this one. So this one, so 6 to the power 4 times. So this one is the third law, 3 to 6. So 6 to the power 6. So this one is multiplication. And the law says through the multiplication we add the exponent. So I have this one. Alright. Now the law only holds if the weights are the same. Don't forget that one. Alright. So I have 6 to the power 10. Alright. With the last example, so can you try this one? So just pause the video and try this one. Alright, so this one, 2, 3, 6, you have b to the power 6 divided by, so this one is 5 times 2, which is 10. 10, alright. So this one is division, and division we subtract. So I'll pick one of the bases, then I'll subtract the exponent. 6 minus 10 is minus 4. So b to the power minus 4. So it's not 4 but minus 4. Alright. Alright, let's talk about properties of indices. Alright. So properties. Alright, now the first one, any non-zero number to the power 0 is 1. So in case you are doing this, a to the power 0 is 1. Alright, so any non-zero number to the power 0 is 1. So 5 to the power 0 is also 1. So 0.045 to the power 0 is 1. Don't forget this one. So that's the first property. Alright. So now the proof is coming from here. So let me prove the reason why this one is got this. Alright. So in case now this one, let's say a to the power 4 divided by a to the power 4. Alright. Now you know that this one is the same as e to the power 4 over e to the power 4. Alright. So let's solve the left and then the right and see. Now, this one, let's apply the law here. The law is using division, we subtract. So e to the power 4 minus 4, which is e to the power 0. So for this side, now this one is also the same as the number of times a multiplied itself is 4. So a times a times a times a over. So this one is a times a times a times a. So this one will cancel this 1 1. This one will cancel this 1 1. This one will cancel 1 1. So this one will cancel this. So 1 times 1 times 1 times 1 is 1. 1 times 1 times 1 is 1. So 1 over 1 is 1. Alright. So we have this 1 e to the power 0 and we have 1. And since this 1 is equal to this, now we can say that e to the power 0 is equal to 1. So any non-zero number to the power 0 is equal to 1. Alright. So any number to the power 1 is that number. So any non-zero number to the power 1 is that. So this one is equal to a. Alright. So the first one, e to the power 0 is 1. And the second one, e to the power 1 is a. So don't forget this one. Alright, so we have this one. Alright. So e to the power 1 is 8. So 5 to the power 1 is 5. Alright, so 6 to the power 1 is also 6. So 17 to the power 1 is 17. Alright, so that's that. Right, let's move on to the next one. Alright, so this one is negative index. So in case we're given a to the power minus 1, now this one is the same as 1 over a. So c to the power minus 1 is the same as 1 over c. So y to the power minus 1 is the same as 1 over y. Alright, so what if here is 2? That is minus 2. So if here is minus 2, so in case we are giving a to the power minus 2, so this one is the same as 1 over a to the power 2. Now the trick here is that the moment you write this 1 over, then the minus will vanish. Alright, so we assume that the 1 is still there. And we know from our second component that any non-zero number to the power 1 is that number. So we assume that here is 1. Okay, so e to the power minus 1 is the same as 1 over a. Alright, so if here is 2, the 2 will come. So c to the power minus 3 is the same as 1 over c to the power 3. So the moment you write this 1 over, then the minus will go. Alright, so that's that. Now let's move on. Now the fourth one. Alright. So in case you are given this one, a over b to the power or to the power n. So this one is the same as, now the power will affect everything in the bracket. So this one is the same as e to the power n over b to the power n. Alright. So in case we're given, let's see, x over y all to the power 2, this one is the same as x to the power 2 over y to the power 2. Alright, so don't forget this one. So in case we're given this 3 over 2 all to the power 2. So this one is the same as 3 to the power 2 over 2 to the power 2. And 3 to the power 2 is 9. then 2 to the power 2 is 4. Alright, so that's that. So don't forget this one. Alright. Now, the fifth one, AB all to the power T. Now, what this one means that the T will affect everything. So this one is the same as e to the power T, then b to the power T. So this one is that. So this one will affect this at the same time this. So example, give you're giving, let's say 2x to the power 5. This one is the same as 2 to the power 5. So this one is multiplication, so times x to the power 5. Or you can also say 2 to the power 5, x to the power 5. They are the same. Alright, so this one is multiplication. Alright, so that is that. Alright. Now, what if here is minus? So let's deal with that one. So in case that is minus. So in case of this one, A will be minus n. Alright. Now, so the moment you see this one minus, this one is the same as, so just interchange this one, so b over a. The moment you do that, this one also change to positive. Alright, so in case you have c over n all to the power minus t. So this one is the same as n over c. Then this one also change. Because the moment you interchange this one, it also change. Alright, so don't forget this one. So in case we're given this one, 6 over 5 all to the power minus 1. This one is the same as 5 over 6 all to the power 1. And in the number to the power 1 is that one. It is the same as straight away 5 over 6. Alright, so it's not very simple. Alright. Now let's quickly move to fractional index. So in here we have a to the power half. So a to the power half is the same as square root of a. Don't forget this one. So every time you see a to the power half, the same as square root of a. Now a to the power 1 over 3. Okay, this one is the same as cube root of a. So this one is this. Now somebody will ask, why is that here is not 2, here is 3? Now this one is the same as this. So if you put 2 here, it becomes totality. Okay, alright. So you can't put 2 here. Okay, it's like saying return back. Okay, that doesn't sound well. Alright, so this one is the same as this. So from 3 going, we put it here. So in case you have a to the power 1 over 4, the same as fourth root of a. Alright. Then if you are given, let's say, a to the power 1 over n. So let's say something. So this is 2, this one is the same as this. 3, you see it, 4, you see it, but 1 over n. So let's get this one. So this one is same as n root of a. Alright. Now, what's something here? You can see 1, 1, 1, 1. So what if here is 3, here is 2, here is 2, here is, let's say 5, here is 6. You see 1, 1, 1. What if you don't see 1, but you see different number? Now let's work something here. Now, this one, we assume that is all to the power, what we see, 1. So this one, we have 1, we assume that is all to the power 1. So this one is the same one, we assume that is all to the power 1 because of the 1, 1, 1, 1. So to the power 1, 1, 1, 1. Alright. Now, and this one Any non-zero number to the power 1 is that number. That's why you don't see the 1 there. But ideally, this one is supposed to be to the power 1, to the power 1, to the power 1, to the power 1. Okay? So in case you're doing, let's say, a to the power 5 over 2. Alright, so here is 5. Now this one is the same as, so I can rewrite this one as a to the power half or to the power 5, because half times 5 is the same as 5 over 2. Alright, and this one, you know this one is this. Okay, a to the power half is here, a to the power half is there, which is this one. So this one is the same as a or to the power with the 5 in there, 5. Alright, so in case you're using this one, a to the power 7 over 2. Now this one is the same as a to the power half or times 7, because half times 7 is 7 over 2. Half times 7 is the same as 7 over 2. So this one can be written like this. So this one is the same as square root of a all to the power 7. So that is foundation. Alright. So this one, let me take my time here. So this one, the power is 5 over 3. So this one is the same as t, okay, to the power 1 over 3 or times 5. Now, in going back, 1 over 3 times 5, so 1 over 3 times 5. So let's make this 1 over 1. So 1 times 5 is 5. 3 times 1 is 3. So 3 over 5. Okay. Sorry, 5 over 3, which is here. Okay. So this one is the same as this. And we know 1 over 3, t to the power 1 over 3 is the same as cube root of that. So cube root of t. So over 5 will also come. Then you do it. That is. Okay. So you want not to confuse yourself. That is how you go about. You don't confuse yourself. Always the top one, bring the top one out. Okay. So we are left with 1. 1 times 5 is 5. And we know how to write this 1 over 3 is same as cube root of that. Now m over c. So m over c is the same as a to the power 1 over c or to the power m. You see the top one always cancels out. Okay, this one 5, see the 5. So 1 over c is the same as the c root of a or to the power m. I hope we are getting it. So this one is 8 over 3. So how do you write this one? So this one is the same as 5 1 over 3 or to the power 8. And this one will give us cube root of 5 or to the power 8. Alright. So let's try this one by example. T over c. T to the power p over c. So this one is same as t 1 over c or times p equals, so this one is t 1 over c is same as the c of t or to the power p. Alright. So let me give you some to try. So this one is the same as 5 to the power 1 over 7 or to the power 9, which is the same as the 7 root of 5 or to the power 9. And this one 3 over 2 is the same as 6 1 to the power 1 over 3 or to the power 3, which is the same as the c root of 6 root of 6 or to the power 3. Alright, so that's that. So these are the examples. Alright, let's consider the following examples. Now I have 2 to the power 1 over 2 times e to the power 1 over 2 all over 4. Alright, so let's use the law, and remind you, before you can use the law, you have to make sure we have equal rates. We have 3, we have 4 here, unless you change something. Unless you change this one, so this one is the same as 2 to the power half times. So let's change this one. We know 8 is the same as 2 times 2 times 2. 2, 2, 4, 4 to 8. So 8 is the same as 2 to the power 3. Now, this number alone is giving us 2 to the power 3. But we still have exponent that is 1 over 2 there. So this one is the same as 2 to the power 3 times, so the half will come. So this one is the third law. So in case you are giving this one, a to the power n, or to the power x, so you just multiply nx. Alright. So I have that. So over, so let me also change this one to 2 to the power 2. Alright, so that you get equal base, that is, you get the base to be the same. 1, 2, 3, the base are all the same. Alright, so let's move on. So let me multiply this one. 3 times half is take away 2 half times. So 3 and half, 3 times 1 is 3. So 2, 3 over 2 over 2 to the power 2. Alright. So I'll deal with the numerator. So this one is multiplication. That's the first law. We said multiplication, if the bases are the same, you can add the exponents. So this one, you can add the exponents. 1 over 2 plus 3 over 2. That is 4 over 2. So that is 1 over 2 plus 3 over 2. So the LCM is 2. So I have 2 there. So 2 into 2 is 1. 1 times 1 plus 3, which is 4 over 2, which is 2. So this one I'll get 2 to the power 2. Alright. Over 2 to the power 2. Alright. So this one over this, they are the same. So straight away, the answer is 1. Or you can say this one is division. So you can perform the law, which is, so this one is division, so I'll subtract. So 2 to the power 2 minus 2, which is what? 0. And any non-zero number to the power 0 is 1. So since this one is 2 to the power 0, which is 1. So this one, the answer is 1. Alright. Alright, let's look at the second example. Now this one, we can use 2 ways to solve this. Now the first method, before we move on to the methods, now I have minus here, minus there. So let's, don't forget this. So in case we are given this one, e to the power minus n is the same as 1 over a. So we are going to rewrite this one so that we get positive exponent. Exponent should go positive. So let's make this one positive by saying 1 over 125 to the power 1 over 3 times 1 over 49 to the power 1 over 2. Alright. So with this, you can use 2 methods. Now the first method I'll talk about. Now I have the power to be 1 over 3. So let's change this number, okay, to a number to the power 3, which will give us 125. So 125, we know 5 times 5 times 5 is 125. So we are going to change this one to 5 to the power 3. So this one is the same as 1 over 5 to the power 3. Don't forget we have 1 over 3 here, so that one also multiply 1 over 3 times 1 over. Now this one here is 2. So find a number, make multiply itself twice, that will give you 49. So we know 7 times 7 is 49. So 7 multiply itself. So 7 to the power 2 times 1 over 2. Alright. Now we are doing this because we want to do cancellation, that's why. So this one will straight away cancel this. 2 will also cancel it. Right. So this one, I have 1 over 5 to the power 1, which is 5. So I have 1 over 5 times 1 over 7. So 1 times 1 is 1. 5, 7, 35. Alright. So that's the first method. So let me use the second method. So I have this one, second method. So this one is the same as 1 over 125 the power 1 over 3 times 49. Sorry, 1 over 49 to the power half. Alright, now we said if this one is 1 over 3, the same as cube root of this, and this one is square root of this. So this one straight away you can say 1 over cube root of 125 times 1 over square root of 49. Alright. So don't forget that we said in case you are given e to the power 1 over 3, the same as cube root of 8, and 8 to the power 1 over 2, the same as square root of 8. We said this one in our properties, so don't forget this. So this one will give you, so use your calculator. So press shift, then press the root sign, give you this one. So make this one 3, or you the 3 there. If you want to move forward, you have to bring the color here and then change this one. Alright. So press this one, let's see. So you get 5 for this one. I have 1 over 5 times, so square root of 49 gives you 7. 1 over 7, that is positive square root of 49. So this one is straight away 1 times 1, 1. 5 times 7 is 35. So this one is the same as this. So whichever way you go, get the same answer. Alright. Alright, my name is Tevi Adam Kwasamuel. We are going to look at exponential equation. So, in case we are given, let's say, a to the power t equals a to the power 5. Alright, so this one, what it means is that the left hand side is equal to the right hand side. So we have a here, a there. It means this one go to this. Alright, so always have to make sure the bases are the same before you can deal with the exponents. Alright, so this one t is straight away 5. Alright, so in case you're also given this one 2 to the power x go to 2 to the power 1. So this one you have 2 here, 2 there, so we can conclude that s is equal to 1. So this one, s is straight away 1. So equation of this nature are called exponential equation. Alright, so let's try the following examples. Alright, so you can pause the video, then try the following questions out. After that, move on. Alright, now the first one we have 2 to the power x equal to 8. So we have to solve for x. Alright, now we have 2 to the power x here, but this one is 8. And per what we've learned, but we have to make sure the bits are the same. But this one is 2, this one is 8. So we have no option but to change this 8 to 2 to the power a number that will give us 8. I'm saying this is a number that will give us 8 because this side is 2. So this one is supposed to be what? 2. Alright. So we know that 8 is the same as 2 times 2 times 2. 2 to 4, 4 to 8. So 2 multiplying itself 3 times gives 8. Alright. So this one is straight away 2 to the power x equals 2 to the power 3. Alright. So this one is 8. This one is also 8 because 2 to the power 3 is the same as this one. So now that we have equal bases, I can conclude that s is straight away 3. Alright. So x equals 3 for this one. Alright. Now let's move on to the next one. Now this one I have 1 over 9 all to the power 2 minus y. 2 minus y equals to y. Alright. So I'll first see this one. We know from the lesson 1 we said in case we're given, let's say, 1 over n is the same as n to the power minus 1. Alright. So in case we're given 1 over n is the same as this one. So we are going to change this one in the form of this one. So let's move on. So this one, I'll take this one and I will say 9 to the power minus 1. Then my 2 minus y will come equals to. Now, this one, we also learned from the first lesson that any non-zero number to the power 0 is 1. So now that we have here to be 9, why don't we write this 1, let's say 9 to the power 0, so that it's equal to this one. Because any non-zero number to the power 0 is 1. So I can say 9 to the power 0, which is 1. So they are the same. I'm using 9 because I want to get equal bases. Alright, that's why I'm using 9. So with this one, I can deal with the exponent. So minus 1 times 2, I'll get minus 2. So 9 minus 2. Then minus 1 times minus y, I'll get plus y equals to 9 to the power 0. Alright, so I have equal bases, so I can equate the exponents. So this one is the same as, so let me solve it here. This one is the same as minus 2 plus y. So this one equals to 0. So this one equals to this. Alright, so y is straight away 2. Alright, so I have y to be 2. This one is a basic equation which I think everybody can solve, right? So by making y the subject, y will stand there and send this one to the other side. Or you can add positive 2 to both sides so that this side will go. Alright, so that's that. Alright, so let's move on to the third example. Now the third example is not difficult. Alright, now let's check something here. I have 1 over 4 all to the power 1 minus x equals 2 root 2. Alright, now don't forget that we said in case you have, let's say, a to the power half, the same as square root of a. We said that. So we are going to change this one. Alright, don't forget this one is 2 times this. So I can say 1 over 4. And since this side is 2, we have no option but change this one also 2 to the power 2, which is 4. So this one is straight away 1 over 2 to the power 2. Okay, 1 minus x equals, so this one is 2 times 2 to the power half, because square root of 2 is same as 2 to the power half. Alright, so this one can also be written as 2 to the power minus 2. Yeah, I said this one in the second example. I made mention of this. So 1 minus x. The reason why this one became this, I said that because, so this one is 1. Check from the first lesson. We said any non-zero number to the power 1 is that number. Right. So 1 times 2 to the power half. Alright. So I have this one. Alright. So I have, so let me expand the experiment. So minus 2 plus 2x equals, so law of indices multiplication, we add the exponents. So 2, 1 plus half. Okay, I have that. Alright. So 1 plus half is 3 over 2. So this one, I can equate this one to this. So this one is the same as minus 2 plus 2x equals, so 1 plus half. Okay. Right, I have this. So I have minus 2 plus 2x. So we have 3 over 2. So let me send the minus 2 to the other side. So 2x equals 3 over 2 plus 2. Alright. So 2x. So let me find this one. So I'll get 2. LCM will be 2. 2 into 2 is 1 times 3. So 1 into 2 is 2. 4. So I have 7 over 2 for this side. Alright. So this one is same as x equal to 7 over 2 all over 2. Alright. So this one is a basic equation. So this one is 7 over 2 over 2. Now in case you are given this one, in case you are given a over b all over c, is the same as a over bc. So this one x is straight away 7 over 4. Or you can use calculator to check that. Alright. For example, so this one is the same as 25 over 100. Because 25 over 100 is the same as 0.25. So this one can be written like this. Alright. So let's do cancellation. 25 here 1 into 100 is 4. So I have 8 to the power y equals 1 over 4. Alright. So let's change this one. And so this one is the same as 2 to the power 3 y equals, with this one also 1 over 2 to the power 2. Alright. So this one is the same as 2 to the power y equals, so this one is the same as 2 to the power minus 2. Alright. So I have that. So this one is the same as 3y equals to minus 2. Therefore, y will give you minus 2 over 3. So you divide each side by 3 and get this one. Alright, so it's not difficult. Now the fifth one, we have 100 to the power x equals 0.0001. Alright, so I have this one, 100 to the power x equals, so this one is the same as, so I'll write my 1 over, so where the point is, I'll put 1 there, then count 1, 2, 3, 4. So I'll make 4 0. 1, 2, 3, 4. Alright. So this one is the same as that. Now, so this one is the same as 100 to the power x. So this one is the same as 1 over 100 to the power 2. So 100 to the power 2 is the same as this 10,000. Alright. So straight away I can say 100 to the power x because 100 to the power minus 2. So we have copies, so x is straight away minus 2. Alright. So this one we have is equal to right. So very simple. Right. So let's move on to the last one, the sixth one. Okay. Now 9 to the power 2x plus 1 equals 81 exponent x minus 2 all over 3 to the power x. Alright. So we have 3 here. So let's take this one to the power a number that will give us 9, then same as 81. Now we know that 3 to the power 2 will give you 9. So this one, 3 to the power 2 is 9. So I'll add 2x plus 1 equals, so this one is 81. Now 81 is 3 to the power 4. So 3 times 3 times 3 times 3, 3 to 9, 9 to 27, 27 times 3. So 3 to the power 4. So I'll add x minus 2. Alright, so this one is giving us 3 to the power 4, that is 81. And don't forget you have x minus 2 there, that's one is here, over 3 to the power x. Alright, so this one is division. Alright, so this one is the same as, so let me expand this one, 3, 4x plus 2 equals, so this one is division, 3 to the power, let me expand the top, 4x minus 8 divided by 3 to the power x. Have we seen that? Because this one is division and this one is division, they are the same. So the law says in the division, you subtract. We have equal ways, so we can subtract. Alright, so this one is same as 3 to the power 4x plus 2 equals 3 to the power 4x minus 8 minus x. Alright, so I have this. Equate the exponents. You have 4x plus 2 equals 4x minus 8 minus x. Alright, so I have 4x here, 4x there, so this one will cancel this. Yeah, so I'm left with 2 here, minus 8 minus x. So let me send this one. So let me send the minus x here to positive. And then let me maintain the minus 8 and then bring the minus 2, bring the positive to bring minus 2, so x is away minus 10. So the answer for this one, the s is minus 10 for this question. Alright. Now, they can also give you the one in the form of quadratic equation and others to simultaneous equation. Alright, so let's try this one. So at times the question may be given in the form of quadratic equation, right? So you can check out from my videos. I've taught how to learn quadratic equation with ease. Don't face any error. But check out my video. So I have a video on quadratic equation which you can learn how to solve quadratic equation. Alright, so let's move on with this. Now I have 2 to the power 2x minus 9 times to the power x plus 20 equals to 0. Now I have 2 to the power x here, and this one I have 2 to the power 2x. So let me teach you something here. So I have 2 to the power x here. So let me write this one So let me write this one as this. So 2 to the power x all to the power 2. Because x times 2, you get this one. So I've changed nothing. Alright. So minus 9 2 to the power x plus 20 equals to 0. Now what can you see here? We have 2 to the power x here, 2 to the power x there. So in order to make this one simple, we have to remove the 2 to the power x by letting a variable be that. So let 2 to the power x be a variable. So let y be 2 to the power x. Which means where you see 2 to the power x, you put y there. So I'll put y here. So I'll put y here. Don't forget I have power there. So I'll add that one. Minus here is 9. And this one is y plus 20 equals to 0. Alright. So this one is a quadratic equation. Alright, so here I said you can check this one out, how to solve quadratic equation from my videos. Alright. Now the coefficient here is 1. Always make sure you multiply what you have here by the constant. So that's the first step if you want to solve quadratic equation using quadratization method. Alright, so here is 1. 1 times 20 is 20. Alright, now after that you find two numbers. When you multiply, you get this 20, but when you add, give you minus 9. So what are the factors? So 5 times 4 is 20, but 5 plus 4 is 9. But here is minus 9. So I'll negate 5 and then 4. So that minus 5 times minus 4, I'll get equals to 20. But minus 5 plus minus 4, I'll get minus 9. So I'm going to replace this one like this. So straight away I will say y squared. So I'll take the first one minus y, then I'll add the y. So then minus 4y. So this one will give us minus 9y. So I've changed nothing. Plus 20 is equal to 0. Alright. So I can factorize y out here. So y out. I'll be left with y minus 5. Alright. So I have y minus 5 here. So this one, let me take minus 4 out. If you take minus 4 out, you will left with y minus 5 equal to 0. Now here is minus. Why? Because if you multiply this one by this, you get minus 4y. So minus 4 times minus 5 gets plus 20. So you are correct. Okay? Even though here is plus. But if you remove the brackets, you still get plus. So I'll show you nothing to the question. So I have this one in common. So I'll pick only one. I'll pick 1. Y minus 5. Then the coefficients y minus 4 equals to 0. Alright. So let's solve this one. This one equals to 0. Y minus 5 is equal to 0. Therefore, y is equal to 5. And also, y minus 4 is equal to 0. Therefore, y 4. Alright. So we said let y be this. We after x, not y. So let's move on. So we said let y be this one. And we have y to be 5 and y to be 4. So 2 to the power x equals 4. Let's use 4. Alright. So this one becomes basic equation. So we are going to change this one. 2 to the power x is the same as 2 to the power 2. Alright. So s is straight away 2. Alright. Now let's move on. So 2 to the power x equals 5. Now this one, we have to apply logarithm, which is not done yet. which will be in our next lesson. So in our next lesson, we are going to teach how to solve equation of this. So equation of this nature, the way we can take this one, we have to apply logarithm on both sides. So that will be our next lesson. Alright, so let's keep this one for our next lesson. Alright, so but this one, since we can express this one, we are getting the same basis. That one, then we know how to do that, so we don't have to go on that. Alright, so let's move on to that. So this one, the answer, one answer is 2. Alright, so x is equal to 2. Alright, so that is that. So let's move on. This is our last example. Alright, so this one is the exponential equation. So this one, it involves simultaneous equation. You have to apply simultaneous equation. So we are going to solve for x and y. So I have x plus 6y equals 3. So this is our last example. So x plus 6y. So this one, you won't touch anything because this one is x plus 6. You can't change anything. You don't have this. So this one is literally x plus 6y equals 3. So this one equation 1. So we don't have to play with the first one. So that one set. Now the second one is where the problem lies. So I have 2 here. I have 1/4 here. So this one is the same as 2 to the power. So this one is the same as 2 to the power. So let me do it here. 2 to the power x plus y. Because so this one is the same as 1/2 to the power 2. Which is the same as 2 to the power minus 2. This one is the same as 1/2 to the power 2. Which is the same as 2 to the power minus 2. So I can say 2 to the power minus 2. Alright, so I have equal basis. So I can say x plus y equals minus 2. So that will be the next equation. Alright, so this one is simultaneous equation. So you can use any of the methods. Alright, so let's move on. I have equation 1, which is x plus 6y equals 3, then x plus y equals minus 2. Alright, so let me use elimination method. Let me eliminate one of the variables. So I have 3 here minus 2 here. So this one is bigger than this. So I'll subtract equation 2 from equation 1. So let me do that. So x minus x minus x plus 6y minus y, okay, then equals sign 3 minus 2. Alright, so we are subtracting this one from this, so this one from this one from that, this one from this, because we have one of the variables common in both equations, so it's easier to use elimination method. Alright, so x minus x is 0, 6y minus y gets 5y, so 3 minus 2, so this one will plus, so 3 plus 2 is 5, so y is literally 1. Alright, now that we have one of the variable, you can use any of the equation to solve for the other variable. So let me use the second equation, which is x plus y equals minus 2. So I'll go back to the second equation, and where I see y, I'll put 1 there, because y equals to 1. So x plus 1 is equal to minus 2. Therefore, x is equal to minus 2 minus 1. So x is straight away minus 3. Alright. So I have x minus 3, y to be positive 1. So let's check from here. X is minus 3, y is 1. So minus 3 plus 1 is minus 2. Alright. So that's all. Alright. Yeah. Alright, my name is Steria Dankwa Samuel. Today we are going to look at this exponential equation. So we have 2 to the power x plus 4 to the power x equals 8 to the power x. Now, to solve this question, first of all, you have to make sure you get rid of the first term. Now, before you can do that, I have to divide 2 by the first, and that is 2 to the power x. So, if you divide 2 by 2 to the power x, so this one, if I divide 2 by 2 to the power x over this one, over that, alright, I'll get something like this. So this one is equal to this, so this one can cancel out. So in our next step, we are left with 1 here plus, alright, so this 1 over this. Now we know from indices that, so we're going to have this one x over y all to the power m is the same as x to the power m over y to the power m. So let's compare this one to this. So this one is 4 to the power x. So this one x to the power m, and this one to the power x, y to the power m. Meaning that you can take this one, then you take one of the exponents, since they are the same. I'll pick only one like this one, and I put this and that into the bracket, then write only one. So this one will be 4 over 2 all to the power x. So I'll do the same to this one, 8 over 2 all to the power x. Alright. Now, this one we have 1 plus. So we can do this one. So 2 into itself is 1. 2 into 4 is 2. So we have 2 to the power x here. So equals this one, 2 to itself 1, 2 here, 4. So we have 4 to the power x for this side. Alright. Now we have 2 to the power x here. We have 4 to the power x here. So let's change this one. So we have 1 plus 2 to the power x. So this one is the same as 2 to the power 2 all to the power x. Yeah. So this one is 2 to the power 2. 2 to the power 2 is 4. Then our x is there. So this one is the same as 1 plus 2 to the power x. So we can multiply this one. So I can say 2 to the power 2x. Alright. Now we can see 2 to the power x in common, because this one is the same as 1 plus 2 to the power x or 2 to the power x. Therefore, to God's a to the power n times m is the same as 3 to the power m times n. They are the same. So this one can be written on this. So 3 times that is 2x. Alright. So let's move on. Now, so let's proceed. So we have 1 plus 2 to the power x equals 2 to the power x to the power 2. So let's represent 2 to the power x by a variable. So let's represent this one by any variable. So let's 2 to the power x be, let's say, y. Alright. So when you see 2 to the power x, you put y there. That's the meaning. So I'll put y there. So we have 2 to the power x, I'll put y there. Then this one, I'll put y there. But don't forget you have to the power 2 here, so I'll add it. Alright. So I have y squared equals sine y plus 1. So let's arrange this one. So let me send this one to the other side. So I'll get 0 here. So y squared minus y minus 1. So this one is a quadratic equation. So I have y squared minus y minus 1 is equal to 0. So we are going to use the method of computing the square root. solve this one. So to complete the square of this, always make sure the coefficient of the term b x or y squared is 1. And this one we have 1 there already. After that, we divide the term with degree 1 by 2. Alright, so I'll move on by dividing the term with degree 1 by 2. And don't forget this one is same as half y. So we have half times y. So minus 1 is equal to 0. So we have this one is the same as y squared minus half y minus 1 is equal to 0. Alright. Now the next thing is to reduce the powers by 1. So I'll do this one by 1, this one by 1, and I'll square the result. So I'll get y, then this one half, and then I'll square the result here. Now after that, you subtract minus, then you square this one. So square this one, minus 1 over 2, square. So minus 1 also follows, go to 0. Alright, so let's move on. So we have y minus half squared. So let me square this one, minus 1 over 4 minus 1 is equal to 0. Alright, so let's move on with that. Alright, so we have this one, y minus half all square minus. So let's add this one. Let me send this one to the other side. So this one is the same as y minus half. So this one will be positive 1 over 4 plus 1. Alright. So this one, y minus half all squared. So this one, 1 over 4 plus 1. 1 over 4 plus 1. LCM is 4. 1. So 4. So 5 over 4. 5 over 4. So what do we do? We have some y. So what do we do? We can square both sides. So y, let's square both sides. Y minus half 5 over 4. So let's square both sides. So this one will cancel this. So we'll be left with y minus half. So the answer will be plus or minus. This one is the same as 5 over 4. Yeah, this one is the same as this. So let's move on. So y minus half. So this one plus or minus 5 over this one is 2. Alright, so y give you half plus or minus 5 over 2. Alright, so let's take y to be positive. So let's equal the positive one. So we have 1 plus 5 over 2 for y. Alright, now let's move on. Alright, we now know our y. So let's move on. We know that 2 to the power x is equal to y. You know this one. So let's find x from here by taking natural log on both sides. So this one becomes power rule. So this one is the same as x, natural log of 2 equal to natural log of y. So let's find x from here by dividing both sides by natural log of 2. So we have this one. So this one will cancel this. So x is straight away natural log of y over this one. But y is what? Y is 1 plus 5 over 2. So let's do our substitution here. So natural log of y, which is 1 plus 5 over 2 all over natural log of 2. So this is the answer. So the when can calculator work? Alright. So this is the answer for the question. That is 2 to the power x plus 4 to the power x equal to 8 to the power x. Alright, if it is the first time you're watching my video, don't forget to subscribe for more videos. Alright, thanks for watching. Still, we are done by Samuel. You are once again welcome back to my channel. If it's the first time you're watching my video, don't forget to subscribe. Alright. So this question has gone viral with a lot of comments, views. So today I'm going to present the correct answer for this question. Alright. So we are going to simplify this one. But before that, let's analyze something here. We have 1 here, we have 9 here. Alright. So we have 3 to the power x plus 1. Then we have 3 to the power x minus 1. Alright. So we know from indices, you can check out from my videos. Indices, I have a full videos on indices. So in case you have a to the power 0 the same as 1. Alright, so any non-zero number to the power 0 is 1. Alright, so I have 3 here, 3 there, and I have 9 here. So let's change this 1 and that so that we get equal bases. Alright, we want the base to be safe. Alright, so this one I'll save 3 to the power x plus 1 plus, so this one is the same as 3 to the power 2, okay, over, so this one 3 to the power x minus 1 plus, so this one is 1. So you know any non-zero number to the power 0 is 1. So I'll make this one 3 to the power 0, which is the same as 1. Alright, so I have changed nothing to the question. Alright, now we also know from the laws of indices. So we learned about the laws of indices in our previous lesson that a, give them, let's say, a to the power x plus 2 is the same as a to the power x times a to the power 2. Okay, so if you apply this here, I'm going to get this one, x plus 2. Alright. Now, so we have this one to be 3x plus 1. So we can rewrite this one as 3 to the power x times 3 to the power 1. Okay, plus 3 to the power 2 all over 3 to the power, so this one will be x times 3 to the power minus 1. Alright, so plus 3 to the power 0. Alright, now let's do something here. Before that, let me see this one here. So I have 3 to the power x times 3 to the power 1 plus 3 to the power 2 over 3 to the power x times to the power minus 1 plus 3 to the power 0. Alright, so we said any non-zero number to the power 0 is 1. The power 1 is that number. Let's not forget this one. Alright. Now, so let's do small factorization here. So on the numerator, we have 3 to the power x times 3 to the power 1 plus 3 to the power 2. Okay. So let's take 3 to the power 1 out from the numerator. So let's do that and see. So if I do that, I'll get 3 to the power 1, which is 3. So this one to the power 1, which is 3. Then I will leverage this one 3 to the power x. Okay, so plus 3 to the power. So I'm taking 3 to the power 1 out. So this one will leverage 1. Okay, alright. So all over. So this one, let me take 3 to the power minus 1 out. And let's see something. So if I take this one out, 3 to the power minus 1 out, I'll be left with 3 to the power x here plus, now here is 0. So if I make it 1, If I make this one e to the power 1, now if I go back, it will be minus 1 plus 1, which is 0. So if I go back, this one times this, I'll get this one plus. So e to the power 1 times e to the power minus 1, you get e to the power 0. That's the trick in the question. Now we have e to the power x plus e to the power 1, which is 3. And this one is the same as this. So I can say this one is 3. Now this one e to the power x plus, so this one is also 3 all over. So 3 to the power minus 1. Then we have 2 to the power x plus 3. Alright. So I have this one. So this one will cancel this straight away. Okay. So we are left with. So we have 3 here. We are left with 3 over 3 to the power minus 1. Okay. Now, in case we are given a to the power minus 1 is same as 1 over a. So let's change this one. So this one is the same as 3 over 1 over 3. Okay. And this one is the same as, so this one divided by this, so it's the same as 3 divided by 1 over 3. Okay. So this one is the same as 3 times 3 over 1, which is 3. So the answer for this one is 9. So the correct answer for this expression is 9. Alright, so don't forget to subscribe to my channel for more questions. Alright, thanks for watching. Alright, we have x plus x to the power minus 1 equals 4. Alright, so we are going to solve this. Now before that, this one, in case you are given, let's say, a to the power minus 1 is same as 1 over a. Okay, so we are going to change this one to 1 over x. Alright, so let's move on. We have x plus 1 over x equals 4. Okay, so this one is the same as, so we have x plus 1 over x equals 4. So I can make this 1 over 1 and this 1 over 1. Okay, so the LCM now is x. So I can multiply 2 by the LCM. So this side, x times x, I'll get x squared plus, so times x, it will cancel, we are left with 1. So equals times x, I'll get 4x. Okay, so I have x squared minus 4x plus 1 is equal to 0. Alright, so let me use computing the square method to solve this one. So to compute the square of the, we have to make sure the equivalent of x squared is 1. Okay, so we have 1 there already. So the next thing is divide the term that will be 1 by 2. So that is this one. So we are going to divide this side by 2. X squared minus 4x over 2 plus 1 is equal to 0. Alright, so we have x squared minus 2x plus 1 is equal to 0. Alright, so the next step is to reduce the powers by 1. So we are going to reduce the powers of x's by 1. After that, we square the result. So I will reduce this one by 1, left with x. So this one left with 2. That I will square the result. Now when we finish, minus this one squared. So minus 2 squared. Then your plus 1 will come. Okay, equals to 0. Alright. So we have x minus 2 squared. So minus, so this one will be positive 4. So we have that plus 1 is equal to 0. Alright. So I have x minus 2 squared. So minus 4 plus 1 is minus 3 equal to 0. Right. So x minus 2 equals to 3. Alright. So I can take root on both sides. So this one will cancel this. So I will have x minus 2 equals to plus or minus 3. Alright. So x is straight away 2 plus or minus 3. Okay. So x is 2 answers. The first answer is 2 plus 3. Then 2 minus 3. Alright. So this is the solution to this one. Alright. So that's that. You can also use the linear quadratic formula to also solve this one. It will work. Alright. So thanks for watching.